Namaste. We have already studied how to use tf.estimator API for training linear classifiers. We will use tf.estimator APIs to train a boosted tree classifiers, which are quite popular in the machine learning community for modeling structured data. The boosted tree model is an ensemble technique that combines predictions from tens and hundreds of trees. Another good point about boosted tree models is that they achieve the impressive performance on structured data with minimal hyperparameter tuning. Hyperparameter tuning is one of the big problems with neural networks, and we mostly need to use specialized services for hyperparameter tuning in neural networks, because there are just too many hyperparameters. So, in this exercise we will use Titanic data set, where our goal is to predict the probability of passenger surviving. We have already seen this Titanic data set in the context of logistic regression. We have already seen Titanic data set in the context of logistic regression, and will not spend a lot of time on exploration of Titanic data set, and will straight away go into modeling the problem with boosted trees. So, let us download the Titanic data set. The Titanic data set already has a training and evaluation split. So, we read training and evaluation data in pandas data frame and pop or remove the label column from the data frame to create another data frame specially for labels. So, we have df train and df eval, df train and df eval as data frames containing features, and y underscore train and y underscore eval containing labels corresponding to train and the evaluation data set. Let us install TensorFlow 2.0 and set a random seed to 1, 2, 3. This helps to make sure that across multiple runs we get the same results. We know that Titanic data set has about 9 features that describes each passenger based on their gender, age, their class, their embarkation town, and some other features. We first convert the features into feature columns. Feature columns work with all TensorFlow estimators, and their purpose is to define features for modeling. Gradient boosting estimator can utilize both numeric and categorical features. So, what we will do is we will convert the categorical features into one hot encoding. For every categorical column, we first obtain the vocabulary, and then we pass the vocabulary to categorical column with vocabulary list, and the output of that is fed into the indicator column, which converts the categorical column or each value in the categorical column into one hot categorical column. Numerical features are fairly easy to handle, and we simply use numerical columns of feature column to represent each of the numerical features. We combine both categorical features and numerical features into feature columns. We can view the transformation of feature columns. We can view the transformations that the feature column produces. You can see the one hot encoding of the feature value 3 over here. Let us look at the dense feature representation of the feature columns, and you can see that all the features are shown over here, where there are some numerical features and categorical features are converted into one hot encoding, as you can see it here. Next, we need to create an input function. These will specify how data will be read into our model for both training and inference. We will use the from tensor slices to create the data set. Here the data set is in memory and is stored in pandas data frame. So, after creating the data set, we shuffle the data set where we set the buffer size to the number of examples, and we cycle through the data sets as many times as we need. Here the n underscore epoch is set to none. So, we can cycle through data set as many times as we need, and we do not really use batching because all the data is in memory, and hence we have dataset.batch operation where the batch size is the number of examples. So, this input underscore function returns a data set which will be consumed during training and inference time. So, we make the input functions for both training and evaluation. At the time of evaluation, we set shuffling to false and number of epochs to ones and number of epoch to 1. This makes sure that we iterate to the training data only, this makes sure that we iterate to the evaluation data only once. Before building a boosted tree model, let us build a logistic regression classifier to establish a baseline for this problem. So, we define logistic regression classifier with tf.estimator.linear classifier and supply feature columns as an argument. We then train the classifier by specifying the input function, and we train for maximum 100 steps. We evaluate the model with the evaluation input function, and finally we print the result of the evaluation. You can see that we got accuracy of 76%, the baseline accuracy is 62%, and we got precision of 70% and recall of 64%. Now, let us train a boosted tree classifier. For boosted trees, there are TensorFlow supports boosted tree regressor and boosted tree classifier. Here, since we are interested in predicting survival or non-survivals, here since our objective is to predict whether passenger survives or not, we are going to use boosted tree classifier. In boosted tree classifier, we specify the feature columns and the number of batches. We specify the maximum number of steps. The model will stop training once the specified number of trees are built, and we evaluate by supplying the evaluation function. Let us train the boosted tree classifier and check the output. So, after training the boosted tree classifier, we see that it achieves accuracy of 82%, which is 6 percentage point higher than the linear classifier. It achieves precision of 78% and recall of 73%, which is also higher than the linear classifier. So, we can see that the model, the boosted tree model performs better than the logistic regression model in this particular data set. So, now we can use the model to make predictions on a passenger from the evaluation set. TensorFlow models are optimized to make predictions on a batch or collection of examples all at once. So, we give the eval input function, and this eval input function is defined on the entire evaluation set. We look at the probabilities from prediction and plot it. So, you can see that there are a lot of passengers which have probability of surviving only 0.1, and there are few passengers who have got probability close to 1. Let us plot the ROC curve with ROC underscore curve from sklearn dot matrix package. For ROC curve, we have to specify the actual labels and the probabilities, and it returns the false positive rate and true positive rate. We plot ROC curve with false positive rate on x axis and true positive rate on y axis. The ROC curve gives us a better idea about trade off between true positive rate and false positive rate.